Hello YouTube. Today at usbcrepair.com, ignore the top line right here. This is for regular power jack repairs. This is for USB Type-C repairs. This is the replacement USB Type-C connector for this laptop, Lenovo Thinkpad E14 G2. I don't keep those connectors in stock, so if you decide to send one of those motherboards to us, please send me an email that I need to order one of those. I might have it in stock in the future, but for right now, each one of those is like 20 bucks. Once the prices come down, I will basically order more. But at this time, this is a ridiculously expensive connector for some reason. Probably because it's only made for this model. So on this connector, you can see that this board got dent here someplace, right here, bent. And I guess the connector itself kind of crooked on the inside. As mentioned on USB Type-C, on usbcrepair.com, the best time to send it in is while this laptop still works sometimes. Once you wiggle it to death, the handshake component goes bad, and it will give 5 volts to the motherboard, but it won't be boosting up the voltage to 20 volts after the handshake. All right, so the most important thing here is to insulate the area around the motherboard because it has a whole bunch of tiny filters. Those are black filters that are seated right here behind the connector. So you don't want those filters to come off the motherboard while you're trying to desolder this guy. Insulate it on this end and insulate it on that end. And once everything is insulated, you can remove this guy right here. The insulation could be used the 3M. This is called high temperature flue tape. Basically, it doesn't come off easily. Can pretty much resist anything up to 550, I think, Fahrenheit. So yeah, let me show you how I'm removing this guy. Again, this channel has a whole bunch of videos, 1,000+ videos of different laptop makes and models. And I got videos on how to take this laptop apart. I believe E14 G2, maybe like from a month or two or half a year ago. So if you need to take it apart, please follow the video on how to take it apart. This video is basically how to replace this guy here. Now, the complication about this connector in particular, because the problem is the second row is hidden under the connector. So it's really hard to solder the second row properly. And it just doesn't matter how many of those I do. It's always a pain to solder the second row properly. And let me show you what I mean. Okay. Alrighty, so what we have here is the soldering chamber, where I am doing all of the desoldering process. So what I'm doing here, I'm just putting some flux on the back, and then I'm gonna put some flux right here on the bottom. The reason we need flux is for the new solder to mix with the old solder. And once the new solder mixes with the old solder, we're gonna be able to easily take this whole thing apart. Now, the reason the solder doesn't want to mix properly right now, because we need to add a little bit more hot air, just a tiny bit. Once you introduce some hot air, the solder starts to melt much easier and penetrates into the motherboard much better. All right, so here, basically I mixed it up. So the next thing is by the way, it would help if you're watching it on a big screen TV. So the best thing is to boost the airflow, not the airflow, the temperature above 400 degrees Celsius. And the whole thing should basically come off by itself. You don't want to rip anything off because otherwise the connectors on the motherboard are gonna be ripped off. It should be coming off by itself. You don't even need to put any sort of pressure anywhere. All right, like that. Good job. So now we're gonna put the whole thing under the microscope. All right, so now that we have everything under the microscope, what we want to do is we want to add some flux here. And then the next thing what we want to do is mix the old solder with the new solder. That way it would be a lot easier to remove all of the excess solder here. All right, and now what we do is we're gonna use the desoldering braid. Ooh, I still have my hot air running. What we're gonna do is bring the desoldering braid right here and try and desolder all of the solder from the holes. All right, and it's not working out well because we don't have the hot air blowing on this thing in order for us to easily desolder that stuff. All right, so what I'm gonna do, I'm just gonna desolder those pads here. All right. All right, so once they're all nice and clean, we would still be able to put some new solder on those pads. I want everything to be clean before I'm gonna do any sort of further repairs on this board. All right. All right. Come on. I would really like those holes to be emptied by now, but they are not coming off. Let's do some stuff here. Let's do here. Okay. Good job. All right, so what I'm gonna do, I'm gonna flip the motherboard, and under the hot air we'll desolder the other stuff. So here. All right, so here what I'm gonna do is something. Oh, shoot. It's hard to film at the same time. Desolder the stuff properly. Here. Like that. And then like that. Good job. Come on. Doesn't want to come off. All right, so what I'm gonna do is I'm gonna put some flux right here. Okay, now I want to make sure that the desoldering braid is soaked in flux. All right, so remove that here. Okay, let's see. Okay. Anyways, need to work on this hole right here. Reposition the hot air a little bit to help me with getting to those holes. Come on. Okay, looks good. Get this guy out. All right, so now we can see that the holes are empty. And this is not optical illusion. Let me show you. Here you see, this is empty. This is empty, that's empty, and that's totally empty. All right, so here, I want to make sure that that pad here, the plastic stuff inside also melted. All right, so this is empty. That's empty. I want to make sure that there's no extra stuff here on the top, because otherwise the new connector won't align properly. So I need to finish off this here. All right. That way I know for sure the new connector will sit in place just fine. Okay. All right, so the goal now is to pre-tin every single what do I have here? Let's see. All right. Yeah, everything is nice and clean. All right, so the goal now is to pre-tin all of the pads with the low melt solder. For the low melt solder, I'm using a different soldering iron because I don't want to mix the low melt solder with the non-low melt solder. Let's see if we can safely add. All right, so the biggest situation is right here. If I add a little bit more here, it will go into that hole. You see, like it did right now, and that way the whole connector won't align properly. So that's what I was afraid of. All right. That. Okay. Let's try and desolder this guy here. Shoot, yeah. That's a situation where I don't want to be in. Here. All right. Let me bring another soldering iron here to finish off, desolder this guy here. Okay. And not exactly what I wanted to see, but looks okay. All right. Okay. Just want to make sure that the hole is still there, because that's where the connector will go into. Okay, like that. This thing right here might not let the connector sit properly. So again, the reason you pay the big bucks is so that I would spend hours working on this kind of repair. There are ways to make it much quicker, but I used to give a lifetime warranty for the repair. I don't give the lifetime warranty anymore, because some people keep the laptop for many years. All right. All right. Yeah, not exactly what I want to be having here. Come on. All right, I think it's as clean as a whistle now. Used to be much cleaner before, but hopefully. I think it's gonna be just fine. It's, let me see in 3D. Do I have any No, it's nice and flush. Okay. Let me take a look at the, yeah, it will be just fine. Okay. Alrighty. Alright, my problem is this board is bent here a little bit. So I'm not sure where is the straight path to. Maybe I should be more concerned about this side, not so much that side. Let me figure it out. Yeah, basically because of those wings, when the board flexes, it pretty much takes out the... Okay, so what I want to do is make sure it's all nice and straight. Like that. All right, yeah. So that makes my life harder when one end is flexed so much. If it would be just sitting on top of it, that would be a totally different story. Anyway, so the goal now is to put whole bunch of flux right here. Whole bunch of flux. And then apply hot air to stabilize this guy in place. All right. Okay. Let me find the hot air. Alrighty. And I need something to keep everything down here. Like that. Well, you see, the whole thing flexes and I don't need that to flex like that. So yeah, that's what makes my life complicated. All right, let's fire up this. Let's fire up this hot air now. All right. Let's bring it down. Ooh, my fingers. Hot, hot, hot. All right. To me, everything looked kind of good, except the piece on the left there. You see? Let me show you. this guy here for some reason is overwhelmingly soldered. Let me see if the other piece is soldered in. Yeah. All right. Looks okay, kind of. I would honestly rotate it a bit this way, but anyways. So let me solder the sides. Yeah, kind of sits there just fine. Okay. Let's solder the sides. Alrighty. Let's solder here. Okay. Let's solder this guy. Right, you see again, the board is bent, so I don't know where is the limit for. All right. So my concern is this guy here. All right, I don't think it's no longer any concern of mine. What I'm doing is I'm borrowing a little bit of solder from the most amount of solder and distributing it to the other places. I know the reflection of the, I don't want to remove the, well, maybe I need to remove the, you know what, hold on one second. Here. Let's see if we can. Right, I figured I need to get some solder off of there. Off of right here. All right. Right, so here we can solder with just a regular solder. Like that, like that. And like that. All right, good job. Excellent. All right, the problem is I can't see anything right now to see if it's sitting well or not. So what I'm gonna do now is run hot air one more time. Right, and that way solder should flow pretty much everywhere. All right. I still have a breach, I think, on the left side, which I need to take care of in a second. But first I want to clean it up so I could see everything much better. Yeah, I mean right there, you see that breach? All right. All right, I had to remove the reflection. Not reflect. Oh, look at that. This one came off the motherboard. Oh, that's not good. Yeah, we got the LED light that was on the side. It needs to be corrected. It needs to go a bit this way, I think, right? I think it needs to be like here, here, and there. Right, that I will take care of. You see, those are the filters I was worried about right here. Those filters needs to be staying in place. And that's the breach I'm concerned about right now. We can zoom in. Like that. Like that. Right? All right, so this breach is what I need to fix. Let's see if we got any other. Okay, so I need to solder that guy. Need to solder this guy. This is fine. Yeah, I still need to solder a few of those. But this is the most important stuff. All right, so can I draw a little bit more solder from you? All right. Doesn't want to go. Doesn't want to. Okay. All right. The problem is this is the only connector I got. So if I mess it up, there is no relief. I think the pins are crooked or something like that, no? Or is it 3 of them are bridging there? Hard to say. How many are bridged right now? 2 or 3? And remember, those are top of the line microscopes with 3D view. And I'm still having trouble seeing what I'm doing there. All right, so we got 2 pins. Okay, 2 pins. 1 and 2. And the rest is just a reflection? Or the rest is just... I don't get it. Or is it 2 pins in there for some reason? All right. Let me increase the brightness. Maybe I will be able to see something better. No more brightness doesn't give me anything. Still, I don't want it to short in any way, shape, or form. No, this is not the way how it's supposed to be. Okay. Looks like we had a breakthrough. Yeah. We had a breakthrough. Alright, don't want to deal with that stuff anymore right there, so everything looks good. Now what I want need to do is clean this guy up. Well, no, let me solder the rest of that stuff here. Alright. Alright, what are we starting with? Let's start with... Now you should understand that the tip of the soldering iron alone is $200. The soldering iron itself is like $280, made in Japan. And the station itself is another $300, I think. So just to do this kind of microscopic micro soldering, I mean, I got a whole bunch of other stations here, but this is the one I use the most. It's like just to do this, it's $1,000. Plus, let alone microscopes, I got 3 or 4, maybe four microscopes here. But this one I use the most often. This was like 1,100 because it gives me a 3D view of the situation. All right. Seems like all of the stuff is soldered fine. I mean, I'm not 100% sure about this one, but looks okay to me. Let me see. That's soldered. All right, let me clean it and see for myself if everything is nicely, if everything is nice. Let me get a brush that was here someplace. All right, here's the brush. Beautiful. Beautiful. Yeah, the only concern is the third leg right there. Third leg from the left. Yeah, it's soldered, okay. And that's soldered, and this one is soldered. Good job. And you can see how well the solder penetrated here between the connector and the board, and here between the connector and the board. Beautiful. Now let me finish this guy right here so it would sit properly, because right now it doesn't sit properly. Let's see what I can do here. Alrighty, so I use the soldering iron to move it slightly out of place. Now we're gonna guide it in place. Like that. Now let's hold it down and use the soldering iron to No, 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 no. No. You know what? Hold on. Need a different hand to move it in place. All right, looks good, right? Aligns perfectly. Now, let's try this angle. Moves slightly from its position, but looks okay to me. Soldered. I'm not 100% sure if it's soldered right here. Let me put some more solder on the sides here. All right, like that. Okay, and let me put some more solder right here. All right, and right there. Good job, excellent. All set. Let me reduce the brightness and see if nothing else got damaged here. All right. Looks wonderful. So all I need to do is I need to clean this whole thing up and be done with it. You see right here, it doesn't show that it's sitting properly, but it's sitting properly. It's just this side right here is bent, so I try to do my best to unbend it. All right. Alrighty. So what I'm using is a lint-free absorbing pad. That's supposed to clean up everything here. All right. All right. Clean up everything here. Let's clean up everything here. All right, so we're gonna test it in a few seconds. I need to air dry this thing. Alrighty. So we switch to this camera. Let's put this guy right here. Let's put this guy right here. So at the moment of truth, we need to test this thing first. Alright, let's make sure this is nice and clean, because the connector is brand new. I don't want to mess up the connector. All right, so it plugs in all the way. That's already a good thing. That means nothing got messed up on the inside. All right, so here we got like that. You know what? Is it zoomed in or something? All right, so let's measure continuity. Let's put this guy right here. And let's put this guy here. So hold on. Don't want to stress the new connector. Let's make something like that. That's too much. How about this guy here? That too much? Okay, so this guy plus that guy. All right. Here. Let's see. I would rather have it. Where would be the best? If only that thing would work. Wrench. All right, so that's something new. Doesn't want to work. It's been working just recently. What a shame. All right, finally figured out why it doesn't want to work. Okay, so here. Well, let's do that. Where would be a better metal? Maybe this guy. All right. Okay. Okay. All right. Okay. All right, so we got no signal on A11, A10 because those are probably not used. A3 no signal. A2 no signal, so A3 no signal, A2 no signal. A4 is fine, A9 is fine, A7 is fine, A6 is 9, A5 is 9, it's fine, A8, A1. Okay, so that bridge that I was trying to remove, it was unnecessary because that side doesn't respond to begin with. All right, so let's try this side here, and let's raise the support here for the tester. All right, so B12, B1 is fine, B4 is fine, B9 is fine, B7 is fine, B6 does not respond, B5 is fine, B8 is fine, A10 does not respond, B11 does not respond, B3 and B2 are not responding, so my only concern is the B6. All right. So that all shows really good so far. Now what we're gonna do is we're gonna plug in the current meter and see how much current we can pull through, and if there are gonna be a handshake happening. If there are gonna be a handshake happening, then we're already pretty much good. Now you see this tip is crooked, so now I put the crooked tip inside of the connector. So the tip is not ideal shape. So I only put this thing inside of that tester because I know. All right. So the good thing is, oh, you see the fan is spinning. So we already good here. All right. And we're gonna flip it over. And again, the fan is spinning and we get 19 volts, 0.7 volts and 0.66 amps. All right. So the job is done. I borrowed that slogan from another YouTuber. Yeah, so the repair was successful. Thank you so much for watching. Please leave a like, subscribe. I will let you know which laptop brands I would buy and which ones I wouldn't, which ones are easy to fix and which ones are not easy to fix. This is usually as much pain as it comes right here. All right, I'm happy that the repair was successful. We got the fan spinning. Basically, this side has two sides. It can go like that and can go like that. upper row and lower row. That's how it works, okay? So if it doesn't work like that, flip it over, see if it's gonna work like that. All right? All right, guys, thanks so much. You guys have a good day and take care. Thanks.